In the last video, we saw how the structure of tendons is made up of these nicely aligned collagen fibers, and that when tendons get injured, the structure of those fibers gets disrupted. I wanted to look in detail in this video at what happens when a tendon actually inserts into a bone. So we saw in the last video how a tendon is like a structural component that connects a bone to a muscle. And you might be wondering how that interface, how we go from tendon to bone structure actually happens. So to say that bone just, or to say that tendon just inserts into bone is maybe a little bit of an oversimplification. What really happens is that you have out here, in the body of the tendon, you have these nicely aligned collagen fibers, and then as you approach the interface between the bone, which is back here, and the tendon, what happens is those collagen fibers get increasingly mineralized, meaning with calcium. Just like when we saw last week just how osteoblasts become mineralized and turn into osteocytes and make up the cellular matrix of bone. As the tendon approaches the bone interface, collagen fibers take on more and more calcium, and they become, as they say, calcified. So that the tendon structure right here, right at the interface of the bone, is almost indistinguishable from bone itself. It's just bone with a little bit more collagen fiber. And as then you move away, you gradually transition from this very, very stiff, rigid, almost bone-like structure to the more springy, stiff but still stretchy structure of a tendon. One other thing I wanted to mention with regards to the collagen in tendons is that this protein, as we'll see in future videos, also makes up ligaments, also makes up cartilage, and is incorporated into bone in the cellular matrix that holds bone together. But of course, most of the strength of the bone comes from those osteocytes that we learned about last week. Now, what's interesting about collagen, it's a protein. If you've done biology, you know that proteins are encoded by genes, specific genes. And there are actually gene sequences, genetic traits that are associated with, for example, a greater risk of Achilles tendinopathy. And those same genes are also associated with a greater risk of ACL tear. And so there seems to be something about the structure of your collagen proteins that dictate the strength of the connective tissue of your body. There's also some genetic disorders that involve disruptions to your body's ability to produce collagen correctly. And as you'd predict, those have negative effects on all of the connective tissue of your body. So tendons, ligaments, cartilage, also skin, things like the cartilage in your ears, and so on. So this is just a few more details on how tendon, which is made up of by these nicely aligned collagen fibers, inserts into bone, and what the sort of the implications of the structure of that collagen are for health.